Hello everyone, so welcome back to my new video. So in this video we are going to discuss how are we going to decompose a given rational function if you have irreducible factors in the denominator or nonlinear factors. Now what do I mean? So far in the previous videos we always had linear factors in the denominator, right? What do I mean by linear factors? They all look like ax plus b, right? A and b are some numbers. I mean, we always had x to the power 1. Well, we had repeated factors, but those repeated factors were also linear, right? So we had like x plus 3 square. So still, this is x plus 3 is a linear fact. It's just it's repeated twice, okay? Now, how about if we have factors where the degree is higher than 1? So for example, something like this, x square plus 1 here. So it's a factor, okay? So already denominator is been already factored for you. So x square plus 1 is a factor and it's degree 2 factor. It's not a linear factor. So what should you do here? So that's the question. Now, first of all, let's get this clear. When you have the denominator, you have to factor is as much as possible. Still we have x square plus 1, we should still try to factor it. That means we should still try to write it as a multiplication of several linear factors. Can we do that here? Can we write x square plus 1 using linear factors? Can we factor it furthermore? Well, the answer is we have to use the quadratic formula. Let's try to use the quadratic formula because that is something that you can use to factor quadratic functions, okay? So this is a quadratic function. The quadratic formula is minus b plus or minus square root b square minus 4ac over 2a, and this is like if you have ax square plus bx plus c, right? Now here b is 0, right? In x square plus 1 there's no x term, so the coefficient of x is 0, so b is 0, right? So b is 0, so minus 0 plus or minus square root b square is then 0 times minus 4 times a is 1, right? Coefficient of x square is 1 and the constant term is 1, so c is 1 over 2. Alright, so 0 minus 4, here it's just minus 4, right? Now here's the question, can you take the square root of minus 4? You can't take square root of a negative number, at least in your level, okay? So that is why you cannot factor x square plus 1 furthermore. Because if you want to do that, you have to take the square root of a negative number. So how do you make sure that you cannot factor a quadratic function furthermore or not? Just use the quadratic formula. I mean, you don't even need certain parts in the quadratic formula. You just need this part, b square minus 4ac, the part that's inside the square root. Now, if this number gives you a negative number, then that means you have to take the square root of a negative number, so you cannot factor it furthermore. So these type of expressions, so let me erase this crap, okay? So these type of expressions like x square plus 1, we call them irreducible factors. And the name makes sense, right? Irreducible, you cannot reduce it furthermore. Alright, so that is how you identify, okay? So if it is a quadratic function, use b square minus 4ac. If it is negative, you cannot factor it. Okay, now moving on, now how do we write the decomposition? Well, we still use what we have learned from the previous videos. Here, even though this is not a linear factor, we have distinct factors, right? So for each of these factors, we will have a fraction, corresponding fraction in the decomposition, right? So for x plus 3, we will have a fraction. So it's a constant over x plus 3, plus we will have a fraction for x square plus 1, right? We just have to use it. Now, what is the numerator? That's the question. What do you think? Now, remember in one of the previous videos, I said numerator will always be a polynomial 1 degree less than denominator. Now here the denominator, you have second degree polynomial, right? Degree 2. So 2 minus 1 is 1. So numerator should be a first degree polynomial. What is first degree polynomial means? It's a linear polynomial. That means bx plus c, something like this. So let's use bx plus c. Now don't use a here, okay? Because we already use a, okay? All right. So that is how you do the decomposition. Okay, easy, right? You just need to figure out whether your factor is further reducible or not. All right, so let's do some adjustments to the same problem. Let's make it repeated. Make it a repeated factor. So now it's x square plus 1 to the power, let's say 3. Okay, perfect. Now, not only we have a nonlinear factor, but it's also repeated. What do we do here? Same thing again, okay? Just like we learned in the previous video, that now here, read this as, how should you read this? What is the degree here? You have a degree 2 factor repeated 3 times, okay? Repeated 3 times. That is how you should read this term. It's not a 6 degree, don't read it as a 6 degree polynomial. Read it as x square plus 1 repeated 3 times. That means degree 2 polynomial repeated 3 times, okay? That is how you should read it. Okay, so moving on, how do you write the decomposition? So for x plus 3, we will have a fraction a over x plus 3. Now, multiplicity is 3, so count up to 3. 1, 2, 3. So for each number, you take the power of x square plus 1. So we have x square plus 1 to the power 1 plus x square plus 1 to the power 2 plus x square plus 1 to the power 3, right? Just like we learned in the previous video. What is the only difference? Well, the way we write the numerator. So what is the numerator here? What do you think? This is a second degree polynomial, so 1 less than that, 2 minus 1 is 1. So this is bx plus c. How about here? What do you think? So is this 4th degree or still second degree? Still second degree, okay? Remember, the way we read it is very different. This is a second degree polynomial repeated twice. So this is a second degree factor, not a 4th degree one. So second degree, so 2 minus 1 is 1. So this is, let's use dx plus e. Okay, use different letters. Now again, this is second degree polynomial repeated 3 times. So second degree minus 1. So fx plus g. That is how you write the decomposition. So the only difference is that numerator change. But same idea from previous 2 videos preserved. Okay. All right. So let's quickly see a couple of more examples. Okay, I have already worked them out. I will just walk you through these examples. So look at the denominator, factor is as much as possible. So we have a quadratic part, try to break it up furthermore. Can you do that? So well, b is 1, a is 1, c is 4, right? In this part, ax square plus bx plus c. So we have to find b square minus 4ac. b square is 1, so 1 minus 4 times a is 1, c is 4, so 4 times 4 is, here 4 times 4 is 16, so 1 minus 16 is negative 15, right? So it's negative, so you cannot factor x square plus x plus 4. All right, so now you write the decomposition. So for x plus 6, it's a over x plus 6. For x square plus x plus 4, so x square plus x plus 4, what is the numerator? This is a second degree polynomial, 1 less than that, bx plus c. Okay, that's it. That is the decomposition. Okay, look at this problem. X plus 2 over x plus 1, x square plus 10 to this square. Now x square plus 10, it's not reducible, it's irreducible. Check the b square minus 4ac thing. You will see that you will get a negative number. So how do you write the decomposition? A over x plus 1. And we have repeated factor 2. So you count up to 2, 1, 2. So bx plus c over x square plus 10 and ex plus f over x square plus 10 to this square. That's decomposition. Okay? All right. So let's see one more final example. Okay. So let me walk you through this example. So we have x plus 1, x square plus 5 cube and x square plus x plus 1. Now x square plus x plus 1 irreducible. Okay. X square plus 5 is also irreducible. Check it if you want. Okay. X plus 1 is already reduced. It's a linear factor. X is also a linear factor. So how do you write the decomposition? Take each factor at a time. So x is a factor. Okay. All right. It's a linear factor. It's just treat it like x plus 1. Okay. A factor like x plus 1. So a over x, it's a degree 1 factor. So a over x plus b over x plus 1. Well, I have already worked it out. So let me explain you this to you. So x square plus 5. So a second degree factor repeated 3 times. Okay. So I have changed the order. It doesn't matter. Okay, the order doesn't matter. So let's focus on the x square plus 5 part. So x square plus 5. So you count up to 3. 1, 2, 3. So x square plus 5 to the power 1. Ex plus f on the top. Gx plus h, and x square plus 5 to the power 2. Ix plus j, x square plus 5 to the power 3. Okay, as we know, right? So 1, 2, 3. We count up to 3. And why we have linear factors on the numerator? Because this is a second degree factor on the denominator. Alright, x square plus x plus 1, it's a second degree irreducible factor and it's not repeated. So it's x square plus x plus 1, just one fraction, but the numerator is cx plus d. That's the decomposition. Okay. All right. So that's it what I have for this video. In the next video, let's solve some problems from partial fraction decomposition before we move on to learn how to find these constants, how to evaluate a, b, c, d, e, and these constants that you get in the partial fraction decomposition. Okay. All right. So I'll hopefully see you in the next video. Bye bye. Thank you.